The Sorites paradox begins with a simple thought experiment. If you take away just one grain of sand from a heap, it still looks like a heap. Remove another, and the answer doesn't seem to change. But keep going long enough, and eventually only a single grain remains. Clearly, one grain is not a heap, yet there's no exact moment when the transition occurs. The paradox exposes the vagueness in how humans use language and categories. We rely on terms like tall, rich, or bald. But where exactly is the cutoff point? The Sorites paradox forces us to face the uncomfortable truth that many of our everyday concepts are not as precise as we like to believe. This puzzle still challenges philosophers, linguists, and even computer scientists who try to define things in strict terms. The grandfather paradox is the classic problem of time travel. Imagine you step into a time machine and travel back decades to prevent your grandfather from ever meeting your grandmother. If you succeed, you are never born. But then, who used the time machine in the first place? The contradiction destroys the very logic of the story. Scientists and philosophers debate possible solutions. Some argue the universe might protect history, making it impossible to change key events. Others suggest the many worlds interpretation. Altering the past doesn't erase your timeline, but creates a new, parallel one. This paradox has become a cornerstone of science fiction, inspiring countless movies, books, and TV shows. It's more than entertainment. It forces us to ask whether free will and causality can survive the idea of traveling through time. The paradox of thrift shows the strange clash between individual logic and collective outcomes. For a single household, saving money is prudent. It means security, stability, and preparation for the future. But if an entire society suddenly begins saving more and spending less, businesses lose customers, production slows, layoffs increase, and the overall economy shrinks. In the end, everyone's financial position may actually worsen, even though each person tried to act responsibly. This paradox became especially clear during economic crises, when governments encouraged spending to keep economies alive. It reveals how interconnected we all are, and how what makes sense privately can have harmful effects publicly. The paradox of thrift reminds us that economics is not only about numbers, but about human behavior on a massive scale. The Fermi Paradox begins with a famous question by physicist Enrico Fermi. Where is everybody? Our galaxy alone has billions of stars, many with planets in the habitable zone. Statistically, intelligent life should not just exist, but should already have spread across space. And yet, silence. We have detected no unambiguous signals, no alien probes, no visitors. Possible explanations are endless. Maybe advanced civilizations are too far away. Maybe they communicate in ways we can't detect, or perhaps they self-destruct before achieving interstellar travel. Another chilling possibility is the so-called Great Filter, an unknown barrier that prevents life from advancing too far, and humanity has yet to discover if we already passed it, or if it still lies ahead. The Fermi Paradox forces us to confront both the immensity of the universe and the fragility of our own future. The Crocodile Paradox is a strange story about logic and self-reference. A crocodile steals a child and makes a deal. The parent must predict whether the crocodile will return the child. If the prediction is correct, the child lives. If not, the crocodile keeps the child. But here comes the twist. The parent says, "You will not return my child." If the crocodile keeps the child, then the parent's prediction is correct, so the crocodile must return the child. But if the crocodile does return the child, then the prediction is wrong, so it must not return the child. Either way, the crocodile is trapped in contradiction. This paradox illustrates the confusing consequences of self-reference, where a statement folds back on itself. It is one of many logical puzzles that demonstrate how language can trap us in unsolvable loops. The buttered cat paradox combines two quirky sayings. Cats always land on their feet, and buttered toast always falls butter side down. What happens if you attach buttered toast to a cat's back and drop it? Logic suggests two contradictory outcomes. The joke imagines the cat spinning endlessly in midair, never landing. Though clearly playful, this paradox highlights how rules, when blindly combined, can produce absurd results. It also satirizes the way people treat folk wisdom as universal truth. In science and philosophy, it serves as a light-hearted reminder. Not every principle can coexist without conflict, and sometimes our beliefs create impossible scenarios. The Omnipotence paradox asks one of the deepest questions in philosophy. Can an all-powerful being create a stone so heavy that even it cannot lift it? If yes, then the being is limited because it cannot lift the stone. If no, then the being is limited because it cannot create it. Either way, absolute power seems self-contradictory. For centuries, theologians and philosophers debated what true omnipotence means. Some argue the paradox is only a trick of language, since even infinite power cannot do the logically impossible. Others see it as proof that human concepts of unlimited power are flawed. The omnipotence paradox is not just about stones. It's about the limits of logic, language, and the human attempt to describe the divine. The Bootstrap paradox explores the mystery of time loops. Imagine you find a notebook filled with advanced equations, supposedly written by your future self. You study it, publish the discoveries, and years later hand the same notebook to your younger self. But then, who actually wrote the notebook in the first place? The paradox creates an endless causal loop with no true origin. Information, objects, or even people can appear out of nowhere, existing only because they are passed around in time. Science fiction loves this concept, from movies to novels, but philosophers take it seriously as a challenge to causality itself. The Bootstrap paradox asks us, can something exist without ever being created? The Barber Paradox, introduced by Bertrand Russell, is a riddle about self-reference. In a certain town, the barber shaves everyone who does not shave themselves, and only those people. The question is, does the barber shave himself? If he does, then by rule he should not. If he does not, then by rule he should. The paradox seems simple, but it reveals deep problems in logic and mathematics. It's closely related to the liar paradox, statements that contradict themselves, like, this sentence is false. Russell used the Barber paradox to highlight flaws in set theory, leading to new developments in modern logic. What starts as a puzzle about shaving actually reshaped the foundations of mathematics and philosophy.